India's Vikram microchip marks a transformative moment for the country's semiconductor sector and technological self-reliance. The Vikram-32, developed entirely in India and showcased at Semicon India 2025, is the nation's first fully indigenous space-grade 32-bit microprocessor, representing a leap forward for both its space program and domestic electronics industry. The Vikram chip signifies India's arrival on the global stage as a creator, not just a consumer, of advanced chip technology. Designed and fabricated by the Indian Space Research Organization's Semiconductor Laboratory, SCL, in Chandigarh, it was first validated in orbit during the PSLV C-60 mission, a crucial test that proved its reliability for future missions. Architecture and performance: 32-bit design, handles processes in 32-bit chunks, enabling substantial memory addressing and execution of complex instructions needed for scientific, aerospace, and defense applications. Floating point arithmetic supports computation with decimals, vital for guidance, navigation, and control systems in space vehicles where precision is critical. Operating frequency runs at speeds up to 100 MHz, sufficient for real-time mission management and system controls. Single 3.3V supply operation, designed for energy efficiency and system integration. Energy efficiency consumes up to 30% less power compared to imported alternatives, delivering longer operational lifetimes in spacecraft or satellites. Durability and reliability: radiation hardened, built using a robust 180nm CMOS process, making it resilient to extreme temperatures, high radiation, and vibrations typical in space launches. Certified for space, qualified to operate reliably within the punishing context of space environments, validated in actual ISRO missions. Software ecosystem: custom instruction set architecture, enables deterministic operation, an essential feature for flight-critical and defense applications. Programming support: initially supports Ada, a high-assurance language widely used in aerospace and defense. ISRO is developing an in-house Ada compiler, linker, assembler, and simulator for the chip, with plans to support C for broader usability. Integrated toolchain: all supporting software tools built in-house, ensuring full security and control over mission-critical code. Strategic applications: space missions, launch vehicles, manages flight controls, navigation, and guidance within ISRO's rockets, where mission success hinges on unwavering processor stability. Satellites and planetary probes: serves as flight computers for spacecraft, facilitating tasks such as data collection, telemetry, and autonomous mission operations. Military avionics: its reliability and ruggedness suit next-generation fighter jets, military satellites, and unmanned aerial vehicles, and so on. The entire design and fabrication occurred at India's government-run Semiconductor Laboratory, using a mature, space-qualified 180nm CMOS process. While not the latest node by commercial standards, its durability makes it ideal for aerospace and defense. The Vikram-32's completion in less than 4 years, since the India Semiconductor mission's launch in 2021, highlights the country's accelerated journey from consumer to creator. In conclusion, India's Vikram microchip is more than a technical triumph. It's a declaration of independence in semiconductor technology and a stepping stone to global leadership in high-reliability electronics. Its resilient design, proven performance in actual space missions, and fully indigenous production signal a giant leap for India. Thank you for watching. If you found the video insightful, hit the like button and subscribe, and I will see you in the next video.